and welcome to our annual roadmap video update from Ampere Computing. We've been doing annual video updates for the past 6 years, and like prior years, I'm excited to share with you what's new at Ampere. First, I want to thank our customers, our partners, and our suppliers for all the commitment, assistance, and dedication they've had in helping Ampere get products to the world. Without the computing ecosystem leaning in, there would be no Ampere. There hasn't been a new CPU company built in the last 30 years that has reached as far and as quickly as Ampere. It's a tricky time in our industry. Whenever the computing and broader technology industry is at an extreme hype cycle, which is really defined as the peak of understanding a new technology is becoming the strategic context for the next decade of compute, the industry takes a deep breath, and we ponder the future. The future of what we're going to build in hardware, what software is missing, what new capabilities or functions need to be created, and so it goes. We're in an extreme hype cycle on AI. This is evidenced by the near panic purchasing of GPU capacity at the expense of all other forms of data compute. This too shall pass. All hype cycles adjust back to a new normal of the going forward industry. Solutions that are lower cost and more practical to deploy and more broadly accessible to a larger set of customers will emerge. At Ampere, we're working hard to enable and build products for that phase of the new normal, the next decade of AI compute. CPUs are not easy. In fact, semiconductors is not an easy business at all. But CPUs are special. They're necessary. We haven't seen a computer built in the past 50 years without one. And general purpose data compute is continuing to grow alongside AI. Looking back on the 6 years, it seems obvious to Ampere, and it did to me, that low power, high performance CPUs that could scale out with linear performance in an air-cooled environment would be what the industry needed to continue its growth. It wasn't very hard to predict that AI in some form would be the driving force. And the ability to do efficient inference queries was going to be a key for cost-effective broad use of AI. So that's what Ampere set out to build, and that's what we've been building for the past 6 years. We have delivered 6 products in 6 years with unmatched power performance for the cloud data center. Later in this video, we're going to update that product line, and we're going to share our AI performance data on our latest products and talk about how AI compute evolves into the future. Today, we're announcing the next step in the evolution of our flagship development, Ampere One. We're extending our product family to include a new 256-core product that delivers 40% more performance than any other CPU in the market. And it isn't just about cores. It's about what you can do with the platform. We have several new features that enable efficient performance, memory, caching, and AI compute. The Ampere One family of products, starting with our 192-core product shipping now, and moving forward with the 256-core product and beyond, is about delivering not only power-efficient performance, but features and capabilities that enable a sustainable, scalable data center for the future. Jeff will be detailing more about the roadmap and the products in the coming section of this video. So now I want to switch gears a little bit and talk briefly about something that matters to all of us, the environment. Computers take power. They always have, they always will. If you don't design them to use less power, then they just get faster and consume more to get there. It's easier to design products that use power as a proxy for performance. The real art is building something that can deliver 30% more performance, or 40 in the case of our new product, at the same power. Today, in the world of AI compute, we would say low power is being able to stay in an air-cooled environment. We believe that the future data center infrastructure has to consider how we retrofit existing air-cooled environments with upgraded AI compute products, as well as build environmentally sustainable new data centers that fit the available power on the grid. These are real issues. I've been talking to you about them for 6 years, and the emerging data center power crisis is being accelerated by this current hype cycle. Products like the ones from Ampere are going to be fundamental to ensuring the growth of the industry and that it continues at the desired pace in the available power. At Ampere, we have twin missions: build the future of high-performance, sustainable computing, and enable a broad industry of partners and users to have access to our products. Creating a horizontal open ecosystem allows Ampere CPUs to be the engine behind many companies' inventions. It's part of our mission. Right now, there's a dangerous dialogue in our industry that's getting only slightly less hype than AI, and that is build your own CPU, or BYO. The complete verticalization of computing by any one company or any one supplier, it just sounds good on paper, but in practice, there's several issues with this concept. None the least of which is that it isn't economically or technologically feasible for most companies. The real danger in this dialogue is the misunderstanding of the computing ecosystem and the open horizontal environment that has spurred innovation and fueled the economic growth in technology for the past 4 decades. It's on a platform of horizontal merchant market silicon that the greatest inventions in the past 50 years have been created. ChatGPT was created on a horizontal merchant market computer that was built with silicon from probably 50+ suppliers in the market. Open platforms create an ecosystem that moves the industry forward. They create jobs, and most of all, they spur innovation. Ampere is an open platform company. We support other silicon suppliers and partners attaching to our compute and building integrated products for different segments of the market. Jeff will talk more about our AI Platform Alliance efforts and other industry efforts to broaden the use of power-efficient AI compute solutions across the industry. Ampere has been on the journey of sustainable, energy-efficient, high-performance compute for 6 years. We have optimized our products to deliver 2 to 3 times the performance of legacy CPUs with significantly less power. We have worked diligently to ensure that we can accelerate AI in our CPU without additional silicon. We've done this with the belief that the industry must find a new direction in AI compute, and that our approach will lead the way to a more efficient, sustainable future in the data center. I started this company to make a difference in an industry that I grew up in. I have spent the past 30 years building high-performance CPUs and compute platforms. I've seen several downturns and several hype cycles, but through it all, one thing has stayed constant, and that is the need to deliver more compute to continue to grow the industry and ensure a healthy, vibrant ecosystem of suppliers. Ampere has pioneered in a direction that has largely been left to the cell phone industry: low power. Low power used to be synonymous with low performance. Ampere has proven that that isn't true. We've pioneered the efficiency frontier of computing and delivered performance beyond legacy CPUs in an efficient compute envelope. It is clear this is the right path for the future of computing, especially given the emerging work we're all wanting to do on AI. I invite you to consider that the future of compute will not be like the last 30 years, and that the solutions of the past are not the approach for the future. Embracing change is the only way to survive it. I'm going to turn it over to Jeff to give you the details on our roadmap from here, and I want to thank you for your interest in Ampere.
As Renee said, power consumption remains the most important factor in the continued growth of compute. More than ever, the industry requires broad solutions that meet global demand, but they must also do so sustainably. The emergence of disruptive technologies, particularly AI, has triggered an exponential surge in data traffic, propelling demand for additional data centers and power. According to a recent report, the International Energy Agency expects data center consumption of electricity to rise from roughly 4% of total US demand in 2022 to 6% by 2026. This isn't just a problem in the US. Data centers are a significant driver of growth in electricity demand in many regions. As an example, in Ireland, data centers consume 17% of the country's electricity, the same amount as all urban residential buildings combined. With AI applications penetrating the market at a fast rate, the IEA forecasts this consumption to double, reaching 32% of the country's total electricity demand in 2026. At a global level, after consuming an estimated 460 terawatt hours in 2022, data centers' total electricity consumption could reach more than 1,000 terawatt hours in 2026, according to the IEA. This demand is roughly equivalent to the consumption of the entire country of Japan. This is why, as the build-out of AI compute accelerates, it is critical to build for maximum efficiency. Search tools, for instance, will see a large increase in their electricity demand when fully integrating AI. The average power consumed by a typical web search today is 0.3 watt-hours, while the typical ChatGPT request consumes 2.9 watt-hours, a 10-fold increase. At Ampere, we're hyper-focused on answering this efficiency challenge for AI. When running the latest Llama 3 8 billion parameter large language model, enterprises may initially default to using an NVIDIA A10 GPU coupled with an x86 CPU. This configuration delivers 30 tokens per second while using up to 420 watts just for the CPU and GPU. Our Ampere UltraMax 128-core CPU running by itself with no GPU delivers that same performance but uses 1/3 the power. The challenge is clear. With 80% of the world's power still being generated from coal, oil, and natural gas, global electricity consumption from data centers cannot and should not increase. In order to be able to take advantage of the advances in AI, efficient technology like that which we have developed and deployed at Ampere must be utilized. The good news is that it's easier than ever to deploy Ampere CPUs for your workloads. Ampere CPUs are broadly available through over 20 Cloud IaaS offerings and over 50 OXM platforms, enabling seamless adoption across public, hybrid, and private cloud. Whether we're talking about AI specifically or all cloud compute in general, there isn't just a single workload, use case, or deployment model. Our end users are seeking to improve their performance, cost, and predictability for critical workloads while doing the right thing for the planet. OpenX has seen this value of Ampere's versatile and efficient solution and are using it to meet their commitment to net zero emissions.
At OpenX, we were the first supply-side platform in AdTech to move entirely into the cloud. And one of our goals was to greatly improve our efficiency by consuming only the processing power we need, rather than provisioning for peak and having hardware sit underutilized the rest of the time. Now, we were able to achieve that, and on top of it, we've been able to continue driving even more efficiency by evaluating new processor types as they're released and moving workloads to them as appropriate. So we were really excited when we started examining the Ampere processors available as C3A machines on Google Cloud. It's not often that you get a significant power reduction and price improvement while maintaining the same performance. That's exactly what we saw with Ampere's ARM-based processors running our high-volume, low-latency ad-serving system. As the first ad tech company to achieve carbon neutral certification and net zero verification, OpenX has been a leader in sustainability in advertising. Our work with Ampere supports our ongoing sustainability efforts, and we look forward to deploying more workloads on Ampere processors.
To address broad challenges like this, the future of compute must address workloads of all types, a broad range of use cases, and a variety of customer infrastructures. How then does the Ampere platform do this? Ampere CPUs run a range of workloads, from the most popular cloud-native applications to AI. We call this AI compute. AI integrated with the data processing, web serving, media delivery, and other applications needed for full services. AI inference is not like training. Training makes up only about 15% of the total AI compute cycles, but is one large task running for many days, weeks, or months. Dedicated AI training hardware might make sense for this usage. However, AI inference is a set of smaller individual tasks running millions or billions of times per second, collectively making up the other 85% of the AI compute cycles. It is an operational workload that is integrated with other services, leading to a mix of AI and general-purpose computing, or AI compute. With our AIO software library, running GPU-free inference on Ampere is not just possible, but easy. Previously trained models can be run using common frameworks like TensorFlow, PyTorch, and ONNX with outstanding out-of-the-box performance. No modifications needed. This democratizes access to efficient compute for the entire AI model community. There are times when a certain model has additional technical requirements or when incremental compute is beneficial. This is why we've collaborated with industry partners like NetInt and Qualcomm to deliver AI compute. With NetInt, we've created a joint solution using their Quadra T1U video processing chips and our Ampere CPUs to simultaneously transcode 360 live channels along with real-time subtitling for 40 streams across many languages using OpenAI's Whisper model. With Qualcomm, we've scaled out with a joint solution featuring their AI 100 Ultra accelerators and our Ampere CPUs to tackle LLM inferencing on the biggest Gen AI models in the world. Let's hear directly from Qualcomm.
At Qualcomm, we started our AI inference journey 17 years ago with early-stage R&D. This led to an industry-first AI cores in smartphones. Several generations of AI cores later, we evolved and optimized our AI cores for a cloud-optimized AI100. Cloud AI100 Ultra is a bespoke solution for Gen AI and LLMs and is our second-generation cloud AI inference solution. The Gen AI and LLM market is experiencing immense growth, and our collaboration with Ampere to deliver a combination of Ampere ARM server CPU solutions with Qualcomm Cloud AI 100 Ultra enables a complete AI server. This not only broadens the access to AI solutions, but also delivers a performance and power-optimized AI system at server and rack scale that delivers up to 5 times AI performance per dollar versus competing GPU-based solutions.
At the heart of AI compute is our Ampere CPU, which provides flexibility across a range of workloads, unlike a GPU. The high-end AI solution that NVIDIA is promoting, DGX, is a 10.2 kilowatt box with a nearly $500,000 price tag. When deployed at scale, it wastes space, data center infrastructure, and delivers only 20% of the inferences per second as Ampere CPUs for an AI model like Whisper. Even worse, though, is that when not fully loaded with AI demand, GPUs can't even perform other computing tasks. Since demand for all workloads fluctuates over time, a solution that can run everything from AI to a web server to a database is optimal. This full set of AI compute is what Ampere is delivering. Ampere CPUs also satisfy a range of other use cases. With the Ampere Ultra family, we tackled the cloud-native use case that legacy CPUs had not: the need for high-performance and predictable CPUs to meet scale-out compute needs in multi-tenant cloud environments. Scaleway has utilized Ampere Compute to address a large range of applications, from scale-out cloud-native using Kubernetes to AI, with their Ampere-based infrastructure. Adrian will discuss how this has helped them achieve maximum cost efficiency and sustainability.
Our Ampere ARM-based instances are meticulously crafted and deployed for energy optimization, allowing our users to handle high computational tasks with a focus on eco-efficiency. With regards to AI, Scaleway's goal is to become a leader in data sovereign regional AI infrastructure, and a key component of that is offering inference services on eco-efficient CPUs, allowing for more sustainable AI in production. And that's what we're planning to do. Later this year, we will be packaging our inference service with our Ampere-based COP-ARM instances for maximum sustainability. And finally, with regards to cloud integration, we integrated our Ampere ARM-based instances with our Capsule products, so our Kubernetes environments, in March this year, which generated a 90% uptick in usage. And so our customers can now leverage maximum scalability while not sacrificing on sustainability of their cloud architectures.
No use case is one size fits all, and we have incorporated features that flexibly address many of them. For example, Flex SKU allows us to use the same SKU to address both scale out and scale up use cases. Our roadmap addresses other varied use cases around core performance, cache usage, and memory bandwidth with future Flex features. We are also building upon the flexibility of our CPUs by utilizing open interface technologies like UCIe. This provides Ampere with the ability to create even more unique solutions across the industry. Within the AI Platform Alliance, we have formed a working group on UCIe solutions, and you'll hear more about the innovative products being created in the future. Lastly, our Ampere CPUs address a variety of customer infrastructures. We are using our Ampere expertise and platform capabilities to incorporate other customer IP into our future CPUs, thus leveraging a broad horizontal platform to scale across the market while bringing unique innovation at the SoC level to a wider set of partners than would otherwise be possible. The net result is an open and horizontal platform of innovation leveraging Ampere's IP blocks. Ampere's world-class cores deliver the highest levels of efficiency, and a broadening portfolio of IPs meet a diverse set of data center needs. Server hardware and firmware. Ampere has developed open source EDK2 and OpenBMC firmware, plus has contributed full server hardware and firmware platforms to OCP for use by the community. OS and compilers. Ampere has contributed to open source OS kernels and compilers, not relying on proprietary compilers that often focus more on benchmark performance than real-world performance. And the application stack. Ampere has broadly enabled open source software. For instance, via our work with CNCF, we provided managed CI from Actuated for GitHub Actions to support community projects. Proprietary walled gardens in both software and hardware inhibit broad industry innovation, leading to a lack of competitive choice. Open source has been a major driver of industry innovation. Ampere is committed to open source innovation. All of these capabilities and innovation comes together in our world-class CPU, and Ampere One is the heart of our product line. Following up on the success of the extraordinarily efficient Ampere Altra family, Ampere One was released last year, and we've been ramping it in the cloud with providers like Oracle and Google. It is the most efficient and scalable platform in the industry with up to 192 cores. You'll see OEM and ODM platforms rolling out over the next few months as we continue the build out. Let's hear from one of them, Supermicro.
Supermicro is famous for providing the broadest product portfolio that is optimized for different customer workloads. This is exactly the case as we work with Ampere and bringing our Mega DC platforms, which are able to support customers for varied workloads, whether it is a very small core count to very high core count, whether it's support for accelerators, for storage, for a large amount of memory footprint, for a lot of I/O. All these things are packaged well in these platforms to provide the right solutions for the customers. As people are trying to look into adopting these platforms at scale, one of the things that often they run into is whether this kind of a platform is going to support them for the next several years. Luckily for us working with Ampere closely, we are able to map that into the roadmap so customers have a continuity in that one. And as people are deploying at scale, one of the other concerns that they always have is the sustainability. We are adopting open standards. We are taking elements such as DCMHS into the platform design. So when people are taking it, whether standard form factor designs are going into the open compute or open standards, any of these things is completely going to be supported by Supermicro. And we are excited to work with Ampere and bringing these technologies to our customers.
As a reminder, Ampere One starts with the Ampere Custom Core, built entirely by Ampere from the ground up and fabricated on the 5nm process node. It features 192 single-threaded Ampere custom cores, large cloud-optimized private caches with 2 meg of L2 cache per core, microarchitectural innovations within the core for the cloud, plus features tailored for high-performance, highly utilized multi-user environments like the cloud. And in AI, Ampere One has 2 128-bit vector units per core, plus support for bfloat 16, in addition to existing native int8, int16, and fp16 support. The result is the most efficient and highest performance CPU in the industry for cloud and AI compute. And it continues our performance per watt leadership, outpacing AMD Genoa by 50% and Bergamo by 15%. This advantage scales to the system and rack level, where performance per rack is an incredibly important metric in today's power-challenged world. For data centers looking to refresh and consolidate old infrastructure to reclaim space, budget, and power, Ampere One delivers up to 34% more performance per rack. These measurements are based on Spec CPU 2017, a synthetic benchmark, and GCC 13, a widely used open source compiler. When we look at cloud-native workloads such as containerized web service delivery using Nginx as a web front end, Redis as a key value store, Memcached as a caching layer, and MySQL as a backend database, Ampere One extends our leadership in performance per rack even more, besting Genoa by up to 58% and Bergamo by 42%. Another way of looking at this is that Ampere One systems deliver the same performance in less space, 15% fewer servers, and 35% less power. As you can see, we've delivered amazing performance per CPU, watt, and rack. Just as importantly, we're delivering our entire roadmap with ease of data center deployment in mind. Just like it is important to stay within your current power and space footprint, it's also important to be able to deploy our maximum core count and highest performance CPUs without needing to overhaul your data center design with liquid cooling or non-standard form factors. Compatibility with industry standard designs is a key focus for us across our entire roadmap. Last year, we walked through the critical features of Ampere One. Now let's go more in depth into a few of them.
Ampere memory tagging helps prevent security attacks by malicious code that exploits buffer overflows. These attacks can overwrite the memory and expose secure data. With Ampere memory tagging extensions enabled, the software memory management runtime associates a key tag with each software pointer in the program and a lock tag with the corresponding data in memory. This ensures that the program's correct key tag accesses the right physical memory address. While a program is executing and accessing memory, the SoC compares each pointer tag with the memory tag. If the tags do not match, an error is flagged and the program execution is halted, effectively preventing a malicious attack. Ampere Quality of Service Enforcement enables controlled allocation of shared cache and memory resources used by multiple apps, VMs, or containers running concurrently on a single SoC while meeting SLAs. In the case of a multi-tenant environment with different requirements, applications are contending for shared memory and cache resources. Each might have their own sensitivities around bandwidth, latency, and capacity. Ampere One ensures allocation of a minimum threshold of shared resources such that a latency-sensitive app is not negatively impacted by another application that might be bandwidth intensive. Here, a latency-sensitive application, such as video streaming, shown in red, has guaranteed allocation of the shared cache. The gray application, perhaps a mail server, has second priority and a smaller guaranteed allocation. And the black application, perhaps a logging utility, has no priority at all. This allows for consistent performance and predictable service delivery across all applications.
192 cores is a great start, but we have a lot more on our roadmap. Memory bandwidth is an increasingly important need for AI compute, and this CPU will deploy into a 12 memory channel platform in late 2024. We'll then expand the 12 channel platform with our 256 core Ampere One CPU. It is ready to go today on the N3 process node. It will utilize the same air-cooled thermal solutions as the existing 192 core Ampere One CPUs and deliver more than 40% more performance than any CPU in market today, without exotic platform designs. While 192 and 256 cores are already pushing the industry to an entirely new performance envelope, you can see that we have even more on the roadmap right after that. AI compute demand isn't slowing down, and neither are we. I can't reveal all of the features yet, but you're going to be blown away by what we're working on. The flexibility of this platform is very unique. And remember, all these products live on with a long product lifetime and make up our wide-ranging product portfolio, from the IPs to the chiplets to the SoCs to the platforms. Coming full circle back to AI, how then are we utilizing our roadmap to tackle the range of future AI challenges? Today, we're leading the movement to GPU-free AI with the Ampere Altra and Ampere One families. There have been over 100,000 new usages of our Ampere AI software library in the past year, and it continues to grow. Oracle has deployed LLMs like Llama and Mistral on Ampere CPUs. Let's hear about it from Karan.
We've actually been running a lot of different tests, including the inferencing tests for a lot of different models like Orcas and Mistral and Llama. And we've actually seen very promising results to an extent where we've seen extensive price performance metrics, almost 80% cost reduction on 1 million tokens, which I think represents a very big savings for a lot of our customers. We announced A2s, which is our next generation of Ampere instances. It increases density, gets much better per core performance, and it also reduces cost. So it's a win-win-win. So we've seen very promising results, and we hope to continue to work with Ampere and the different model vendors to continue to improve that performance over time. And we're very excited for customers to use it.
As you saw from our work with NetInt and Qualcomm, we are also using the AI Platform Alliance to build hardware solutions in innovative ways to deliver the full spectrum of AI compute. The next step is to build AI-optimized bundles with partners to combine hardware with software, and then take the solutions to the next level of integration with UCIe via the AI Platform Alliance Solutions Workgroup. At Ampere, we continue to meet our customers' goals by using our innovative approach to CPU design to deliver energy-efficient, high-performance AI and cloud computing for sustainable data centers. While others are either standing still in legacy, building proprietary walled gardens, or attempting to fragment the market into unscalable or inaccessible solutions, Ampere is building the open AI compute platform of the future. Broad solutions for a sustainable future that scale across the market and are available to everyone.